from Voyager 2 in our electronic library.
Finally, the end product of this remarkable set of links and relays is a hard copy which comes out of this machine showing, in this case, the wonders of Europa, which were recorded for the first time in human history today. It is absolutely astonishing. See, Voyager 1 got very good pictures of the other 3 big moons, Galilean satellites of Jupiter, but not of Europa. It was left to Voyager 2 today to get the first close-up pictures of Europa, where we see things that are only a few kilometers across. And at first glance, it looks like nothing so much as the canal network of Mars that Percival Lowell imagined to exist on that planet. We see an amazing, intricate network of crisscrossing straight and curved lines. Are these straight lines ridges? Are they troughs? Is it connected with plate tectonics on the Earth? How does it illuminate the other satellites of the Jovian system? At this moment, the vaunted technology has produced something astonishing, but it remains for the limitations and cleverness of another device, the human brain, to figure it out.
Fortunately, we have plenty of pictures to help us.
What about Gene's idea of geysers down the troughs?
Geysers down the troughs? Well, you got to have a mechanism to drive it.
Larry Soderblom, Voyager imaging team.
Some wild idea a few months ago that we might have sort of champagne bottle models. And what that is you seal the crust and you have liquid underneath that solid crust.
The question is, do you have that kind of condition, which is an explosive?
Lonnie Lane, deputy project scientist.
Over a large area, and I thought you'd have enough resolution with some of these pictures that you don't see something that is spread laterally.
Do we have the high-resolution piece to blow up?
Yeah, it was here somewhere.
There it is.
There you go.
Yeah. This is where we pick out the relief, and if we're going to see the things we can recognize. This is what I was
Weeks after the pictures from Europa were received, we were still debating what was in them.
It's as if we almost got to the, here's another thing, look at the little mesas here.
Yeah, very bright.
We almost got to the limit of resolution required to see the craters which would last indefinitely on a crust this thin.
Apart from the Rousseaus, there's a set of very fine, small dots, markings, which are mostly in the model terrain. Like those guys. Now, do you think those are sites of outgassing, calderas, fumaroles, solfataras?
I don't know, but I'll tell you one thing I just picked up. Let's look at this.
Yeah, all right.
Look right here. It disappeared. Look right there. Look at
that's
you see the central peak?
Yep.
You see
a little hole.
Yeah, it's I almost see a radiant crater. I think it's got to be an impact crater. Look at the central peak on it.
There's almost no impact craters on this planet.
Well, wait. We just found one.
Almost none. Therefore, finding one which is alleged to be the exception.
No,
maybe it's not the exception, but something else.
Perhaps, but on the other hand, you asked about all those little holes that we can't quite make out.
So you'd argue that the
resolution limited on these.
The big craters go away by some rheological deformation, and the little ones stay, but they're just at the edge of our resolution.
That's because they're 1/10 the depth of the solid, the rigid crust.
Well, maybe.
Computer processing of the pictures has revealed at least a few features on Europa which seem to be impact craters, but something has wiped out the big craters. Computer processing also played a major role in one of the most amazing Voyager discoveries made on the moon next door to Europa, a world called Io. Even from Earth, we could tell that Io had a strange color. We knew that somehow sulfur had been removed from its surface and ejected into a great donut of gas orbiting Jupiter. Then, Voyager 1 sailed close to Io. There were a few places on Io which looked like the mouths of volcanoes, but it was hard to be sure. Then, Linda Morabito, a member of the Voyager navigation team, used a computer to enhance a picture of the edge of Io in order to bring out the stars behind.
4 days after the Voyager 1 encounter with Jupiter, I was looking at an optical navigation frame Now, in enhancing this particular quadrant, became very evident to me was an anomalous crescent in the upper left-hand corner just off the limb of Io.
What was it? The plume turned out to be exactly in the position of one of the suspected volcanoes.
So basically we realized at that point that what we were observing was a volcanic plume, and in fact a volcanic eruption.
Voyager had discovered the first active volcano beyond the Earth. We then found that Io has many volcanoes. There are at least 9 intermittently active plumes and hundreds, maybe thousands of extinct ones. The plumes can eject sulfur and other atoms off Io altogether and account for the sulfur clouds surrounding Jupiter. Rivers of molten sulfur flow down the sides of the volcanic mountains and are the probable source of Io's distinctive colors. The volcanoes may be tapping some vast underground ocean of liquid sulfur beneath a surface that is only a few thousand years old. So far, in our voyages to the outer solar system, we humans have stayed home and sent our robots and computers to explore in our stead. Someday, perhaps, we'll go ourselves. But suppose, like those Dutch sea captains of the 17th century, the computers aboard Voyager could keep a ship's log. That log, a combination of the events of Voyagers 1 and 2, might read something like this. Day 1. After much concern about provisions and instruments, we successfully lift off from Cape Canaveral on our long journey to the planets and the stars. Day 13. We have taken the first photograph of the Earth and Moon as worlds together in space. A pretty pair. Day 170. A problem in the deployment of the boom that supports the Science Scan platform. If the problem is not solved, we will be unable to take most of our pictures. Day 207. Boom problem solved, but failure of main radio transmitter. If the backup transmitter also fails, no one on Earth will ever hear from us again. Day 215. We cross the orbit of Mars and enter the main asteroid belt. Day 570. We can now make out finer detail on Jupiter than the largest telescopes on Earth have ever obtained. Day 640. The cloud patterns are distinctive and gorgeous. No painter trapped on Earth ever imagined a world so strange and lovely. The white clouds are ammonia crystals, high and cold. We do not know the nature of the red-brown clouds. Maybe phosphorus or sulfur is a stain, or perhaps complex organic molecules of the sort that led 4 billion years ago back on Earth to the origin of life. And what is the Great Red Spot? It is an immense swirling column of gas reaching high above the adjacent clouds, so large that it could hold half a dozen Earths. Its motion hypnotizes us. Some think that the red spot is a great spinning storm, 1 million years old. Day 650, Encounter, a day of wonders. The ship maneuvers so we can take pictures of the multi-ringed basin on Callisto. Images of the astonishing lined surface of Ganymede. A close passage by Europa. And a view of volcanic Io. We successfully negotiate the treacherous radiation belts and accomplish the ring plane crossing. Looking back, we marvel at the rings and see the sun emerge from behind the giant planet. We are outward bound on our